So this is called a periodic function. It repeats itself. We're just going to investigate this, play around with it for a little bit, and then we'll talk about some three major parts I want to look at with these periodic functions, okay? This particular periodic function looks like it starts up here at 1, goes down to -1, then right back up to 1 again. Then it goes down to -1 and right back up. Does this seem to happen at regular intervals? Absolutely it does, and that's why it's called periodic. It has what we call a cycle, okay, and it repeats itself on that same cycle over and over and over again. What we want to do is we want to identify what's called the period, and the period is the length of time it takes for it to repeat. So as you can see on this one, if it starts at 1, it goes down, back up, down, back up, down, back up. You can hear the pattern, down and up. So one cycle happens in how long does it take for one cycle to happen? 360. So the period of this particular graph would be 360. All right. So just like it says, the horizontal length of one cycle is a period, and this period is 360 degrees. That's how much length it takes to repeat one cycle. Now something else we're going to talk about is going to be called the midline. Midline. Okay? Now, this graph goes on forever to the left and forever to the right. This graph in particular may not go to the left. It's kind of hard to tell. But even though it's not listed here, when I look at this arrow, do I think the graph goes down like this? Or do I think it repeats itself? Okay, this type of graph with this arrow does mean that it's going to repeat itself. So even though it's not listed, this graph will repeat itself continuously forever, right? So, I know that's a pretty ugly graph. So the midline, is it possible to have a middle like this up and down? Not if it goes on forever. But is it possible to have a middle left and right? Yes, it is. Now, I'm going to get rid of that red because it's a little bit sloppy. But let's just look at the blue part of it. Where's the middle of this? It is at 0. That's exactly right. So the middle here is at 0. Okay? And that's, oops. The middle is at 0. And that is a line, right? What line would that be called? Y equals 0. Okay? And what that means is the graph is exactly half above it and half below it. Which leads us to our next word. How high above the graph does it get?
1.
It goes exactly 1 above the graph. Okay? It has a height of 1 above the graph. How low does it go below the graph? Well, I know what you mean by the -1, but it's still 1, right? It goes 1 below it. All right, that's called the amplitude. And those are the three words that we need to be familiar with. Okay? We need to be familiar with amplitude, which is the height above or below the midline. I know some of you will want to write that down.
Is the midline always 0?
No. Amplitude is the height above or below the midline. And the midline, of course, is the average of the min and the max. Now, we were just kind of talking our way through midline, but let's try the whole average thing and see if that still works. What is the minimum value that I find on this graph? -1. What's the maximum value? 1. So, just as to double check, 1 plus -1 divided by 2, that's 0, right? And that's the midline. Okay? Find yourself a starting point. To me, it looks like it starts right here at 1. Now, I'm going to physically describe it. I'm going to say it goes down, over, and up. Down, over, and up. Can you hear where it repeats? Okay, down, over, and up. That's going to be one cycle. So if that's one cycle, can you describe to me how long the period is? Okay, in this case it is pi units. Now I know that is extremely weird for you because we haven't used that kind of units yet. But it's clearly written on the graph, so it's definitely pi units. So I'm looking at trying to find the midline now. I want the average of the min and the max. What's the minimum on this one? -1, and the maximum? +1. So just like on the last problem, this is going to end up being a 0. So my midline is 0. Okay, so the amplitude is going to be how high above or how high below the midline it goes. And this one it goes how much? Just 1. So domain and range, I forgot about it. Let's make sure we do domain and range. Let's see, the domain. Okay, there's two ways I can interpret this one. Generally, I think most people would say that theta, and I'm using theta instead of x because that's what they drew on this. See, they called that a theta. It's the Greek letter theta.
What is it?
Okay, it represents an angle. We normally use x to represent any variable, and I'll use x a lot, but when we talk specifically with trigonometry, we're always dealing with angles, and they like to use theta.
Can you draw that?
Theta is a circle. Uh-oh. Why is it doing that? Come on now. Oh, very easy, yes. So this is our basic sine graph. Basic sine graph. It starts at 0. It goes up to 1. From 90 degrees, it goes from 1 back down to 0 again. At 180, it switches from positive numbers to negative numbers, and then it goes down to -1. And then at 270, it starts to curve back up to 0 again. That's the basic sine graph. You guys are going to need to know these points here. Not necessarily memorize these points as much as memorize the fact that the sine starts at 0 and goes uphill first. It goes uphill first. Also, the sine looks like a little S, doesn't it? Okay. Now, talk to me real quick about the main features of the sine. Talk to me about the midline. Is y equals 0? Yes, ma'am. Talk to me about the amplitude.
1.
Is 1. And talk to me about the period. It's 360 degrees. It takes 360 degrees for this regular basic sine graph to repeat itself. Now again, this is the parent function. So we're going to take this parent function and we're going to change it just like we did all year long. We're going to make it skinnier, fatter, taller. Shift it to the left, shift it to the right, shift it up and shift it down. Last thing to talk about would of course be domain and range. Yes, the domain is all real numbers here. It is theta. I'm sorry. Theta is all real numbers. You can choose any number you want to for theta, but you will only get out what types of numbers? Numbers between -1 and positive. Again, the cosine uses the same scale as the sine, 0, 90, 180, 270, 360. But it starts at 1, goes down to 0, from 0 down to -1, -1 back up to 0, and then back to -1. And then, of course, even though we didn't draw it, it repeats itself in both directions. Just like the sine graph repeats itself in both directions. We just didn't write that down. All we did was show one period. So guys, these are the key points to know. The biggest key point you need to understand between cosine and sine is that the sine starts at 0, 0 and goes up. The cosine starts at 1 and goes down. But other than that, they're the same. Now, midline, amplitude, period, domain, and range, are all exactly the same.
Thank you.
So instead of rewriting all those, just understand they're the same.
How did you get to 360?
What happens? So if I were to continue this backwards, it would hit 0 at negative 90. And now I'm just going to get rid of something. Now compare those two graphs.
They look exactly the same.
They do. They are exactly the same. They are absolutely exactly the same. And that's something we need to know. We need to know that the cosine graph, the cosine of theta, is exactly the same as the sine of theta if you move the sine of theta which direction? To the left 90. How do you move it to the left 90? You add 90 to the inside.
Subtract 90 from
Okay.
cosine x and it looks the same.
So cosine is a translation of sine. Anything you can do with sine, or excuse me, anything you can do with cosine, you could also do it again with the sine, just translate it. But I do want you to realize that on page 865, there's a good way to look at this, and that's what we're going to practice with right now. We're going to practice this from 865, knowing the amplitude is in front when you multiply. Period is if you multiply theta, or x. A phase shift happens if you subtract or add from theta on the inside, and a vertical shift moves the midline up and down. And that's what we're going to look at next. This B right here, this B is not the period. It helps you find the period. You take 360, which is the normal period, and divide it by B. It's very easy, okay? And we're going to do an example right now, okay? So I'm looking at y equals 3 cosine x. Midline. Midline is affected by a vertical shift. Does this graph shift up and down any?
No.
No. So right here, there's no vertical shift. So the midline is y equals 0. It doesn't change. It's the same as normal. Normal would be 0. That's right. The amplitude. The amplitude is the 3. It's the A. Okay, so right there's my A is my amplitude. So amplitude is 3. So once I know that my midline is 0, I know it's only going to go 3 above that line and 3 below it.
Period is 3.
It's
Just
120.
kidding.
And for the period, what I need to do is I need to identify the B. What's the B?
300.
Okay. Remember, B is right in front of the X. B is right here. What is it? It's 1. So that's going to be 360 divided by 1, which is 360. So in other words, this is a plain old normal graph.
Except other than amplitude.
Okay. Now, I'm going to come over here to this. I'm going to use this graphing area. First, I'm going to graph a normal cosine graph, and then I'm going to try to graph the 3 cosine x graph. Okay? This is just my standard cosine graph. It's going to start at 1. At 90, it goes back down to 0. At 180, it's negative 1. 270 is back to 0, and 360 is at 1. In other words, it looks like this. Now, that looks a little flatter and skinnier than the last one because I used a different scale. Now, my new cosine graph, in other words, my 3 cosine x, my 3 cosine x graph is over here. My midline is still 0. That doesn't change. My amplitude is now going to be 3. But most importantly, the period has to happen in the same amount of time. So it has to start and stop in the same amount of time as my normal one. So instead of starting at 0, 1, where am I going to start? 0, 3. Then it has to stop at 363, right? Where's it going to be at 90? It's going to be at 0, that's right. 3 times 0 is still 0. Where's it going to be at 180? 3 times negative 1 is negative 3. 3 times 0 is 0. My graph is much steeper. And then it would repeat itself, of course. And I don't have to do those. So on this next problem, y equals sine of 3x. I want the midline, amplitude, and period. Excuse me. Midline. Does this graph have a vertical shift up and down?
No.
No, it does not. I would need something out here, plus 3. That would be up and down. But this one doesn't have a plus. So this is no k, right? So no vertical shift. And if there's no vertical shift, then the midline is just like the normal sine, it's y equals 0. Amplitude is 1, yes ma'am, because right here in front, there's a 1. So the amplitude is 1. So this is basically a normal graph, right?
The period is 120.
All right, the period has changed. This 3 represents the letter B, right?
Yes.
So the period is going to be 360 divided by 3. I forgot to mention that B was 3. And that is 120, which means this period, this graph, has to start and stop in 120 degrees. First I want to do is I want to come over here and I'm going to graph a normal sine curve, and then I'm going to graph what the smaller sine curve would look like. Normal sine curve start. Okay, it's going to start at 0, go up to 1. I forgot to label my axis. I'm going to do this one as a 1 here and a negative 1 here. Yeah, I skipped 1. So it starts at 0, goes up to 1, back down to 0, down to negative 1, and back to 0. In other words, looks like this. Okay, and of course, it does keep going, and it does repeat itself. That's my normal sine curve. Now, my new curve has the same midline, doesn't it? It has the same amplitude. But the whole thing has to happen, start and stop, in 120 degrees. Now, it might be a little hard for you to read this, but I'm counting by 30s. That's 0, 30, here's 60, 90, 120. Right here is 120.
You just move it.
So I need to start at the same spot. That's 0. I need to stop at 120. I have to get up and down and back again before I get to 120. So I want you to think for a second. Look at the original graph. What's half of 360? 180. So halfway I was at 180. What was that value? 0. Okay. What's half of 120?
60.
60. So at 60 I should be at 0. Now I know that halfway between 0 and 180, I reached my tallest point. I reached 1. So what's half of 60? 30. So I got to get all the way up to 1 at 30. It's got to go all the way up to 1 and then back down again.
That means it's 90 and go back.
And that's exactly right. That means at 90, I have to be down to negative 1. And that's what one period would look like. Now, of course, that repeats itself over and over again. I don't need to do that. But it does repeat itself over and over again.
Do we do 860?
You do 860 and page 869, and then back up and do page 859.